Lyryx Lab 12. Question 1. It's given to us that this is annuity due. So the only thing that we have to identify whether it's simple or general. So we want to check number of payments per year and number of compounding periods per year. We're identifying that payment paid in the row is every half a year, so 2 payments per year, and number of compounding period per year is 2. So if P over Y is equal to C over Y, that's a simple annuity due, and we're going to use I is equal to J over M. In our case, J is equal to 0.0725 divided by 2. We're asked to find present value due, and the term 12 years and 6 months, that's 12.5 years. So from here we'll see that N is going to be equal to T times 12.5 years. So that gives us, T is 12.5 years times 2 payments per year. So that gives us 25. And at this stage we'll write the formula, copy down from your formula booklet, that present value due is equal to payment times 1 minus 1 plus I, not I sub 2, just I, because I is equal to J over N, simple, to the power of minus N over I, and then times 1 plus I. We have everything known in here, so the only thing that we need to do is substitute, and at this stage we can use calculator to evaluate that. So we have 25 for N, 725 for I, and then present value is 0. Payment is $600, so that's negative, so use this, negative 600. Future value is 0, P over Y is 2, C over Y 2, and then we have to make sure that we're using annuity due, so the payments at the beginning of every payment in the row, so that has to flash, so press enter in here, then scroll up to present value, and alpha, enter, and this is the answer, 10,109 and 75 cents. For TI Business Analyst 2, we're going to put N is equal to 25, I over Y is 7.25, 7.25, I over Y, then second function, I over Y, and want to make sure that we have 2 payments per year and 2 compounding periods, which we have, that's fine, so enter that. And then present value, next button is present value, so that's 0, present value, and then payment is $600, let's take a look, yeah, payment is 600, so we got 600, change sign for payment, and 0 for future value, and you have to make sure that you have a BGN in here because this is annuity due, and if you don't, then you have to go second function payment, and you go second function enter, goes to END, second function enter goes to BGN, so whichever annuity you have to make sure that you have correct display in here. So cancel and then compute present value, we have the same answer as before. In the next question, we have a question on leases. Leases are annually due because the first payment is at the beginning of every payment interval. So we're going to use the formula, and the formula basically says that suggested retail price minus down payment has to be equal to, that's the amount of financing. Amount of financing is going to be equal to present value of all payments plus present value of the residual value. So it probably would help us if we have some kind of timeline and graphical representation of this problem. So this is amount of financing, so that's 74,000 for this question in here, 74,500 minus down payment of 5,000. That's present value due. And then we're going to have a first payment right at time 0, and we have unknown number of payments. At the end of the payment interval, we have to pay also residual value. So residual value in here is 34,291, and each individual payment, which we don't know, n is unknown, but each payment in here at the beginning of every payment interval, last payment interval is right in here, and the payment is given as equal to 1,366.57. And again, we see that it's monthly compounding and payments are also monthly. So P over Y is equal C over Y. Therefore, we're going to use I because that's a simple annuity due. So if we substitute into our formula, we're basically going to say that amount of financing has to be equal present value of this unknown payments, number of payments in here of 1,366.57 plus present value of 34,291. So if we substitute all those values, we see that the only thing is unknown in here is n, because I is equal to j over m, so it's 0.09 divided by 12. So this value, once we evaluate with this unknown n plus this value, has to be equal amount of financing in here. So at this stage we can use your calculator. Again, we have to make sure that it's BGN, so we have BGN from before. Second function, clear TBM, and n is unknown, so we're going to put 0 for n, 9 for I over y. Present value is going to be 74,500, 74,500 minus 5,000 down payment equal, and that's a present value. Then we have to make sure that we have also a second function I over y, and we have 12 payments per year, so we have to put 12, enter, and 12 compounding periods per year. So that's what we have in here. Then the next thing we have is the monthly payment that is given to us, so we have to enter that as negative, so that's 1,000 366.57. Change sign for payment. And then at the end of the list we still have to write this check for the residual value of 34,291. So that's going to be negative value again, 34,291, 291, and change sign and future value. And then compute n. N is equal to 36. So solving for n, we get n is equal to 36 monthly payments. If we use TI-84, so in this case n is equal, it's going to be 0. Then we have to go down. Nominal rate is 9%. Present value is going to be 74,500 minus 5,000. Payment is negative 1,366. So this is this negative in here. 1,366.57. 7, and then we go to future value, which is also negative because we have to make write another check for 34,291, and then number of payments per year is 12. Number of compounding periods per year is also 12, and then we have to make sure that we have the gain, BGN, and then scroll to N, alpha, enter, and we have 36 payments. And we stop right here.